All right, so these are our derivatives for our hyperbolic functions. And just to show you where they came from, because it's not that complicated, if we take our hyperbolic cosine and we write it, we can now find the derivative. So this is just the derivative of e to the x over 2. And so we can just pull that half out if we want, but I'm going to just leave it like this, over 2. And so we end up with e to the x over 2, no change. And then we would get minus e to the negative x over 2 because we'd have to take the derivative of the exponent. And so you can see, what does this form? It's our sine right there. So derivative of the cosine, hyperbolic cosine, is sine. And so if we did it again with sine, that same idea would happen. That negative would cancel, taking us back to our hyperbolic cosine. So our same rules apply. If you see just one t, this is just chain rule. So what you want to do is make sure you isolate those parentheses. And so we're going to first start with the natural log. So the natural log means we take 1 over, and whatever's inside, that is our denominator. So that's our first start. Now we move on to whatever's on the inside. And you know me, I like to write it off to the side. So we're going to write hyperbolic sine of t. And if you want, you can put inside equals. And then we're going to find the derivative of the inside. So this would become hyperbolic sine. Derivative is hyperbolic cosine. Like that. And then we would continue to the inside of the derivative of the inside, but that's just t. So we're done. So if you wanted to put a parenthesis around it, just so you can see, it's just 1. So we put hyperbolic cosine of t. And then now you can actually see we can do some simplifying. So hyperbolic cosine over sine, well, that's hyperbolic, not cosine, hyperbolic cotangent of t. I'm going to put parentheses because it looks weird. So there's our derivative of t. Why did I put x? Because it's a simple error. You just got to check these things. All right, so our coth of t, hyperbolic cotangent of t, is our derivative. All right, so now exponentials, same thing. This would be y prime equals, and this is also chain rule. So I'm going to highlight it. And you know, with exponentials, you just rewrite. And then we're going to take our inside and write it off to the side. All right, so now the derivative of that inside is equal to, well, this is hyperbolic cosine, and we already knew that would be hyperbolic sine. So I'm going to highlight again. Highlight, come on, highlight. Now I have to re-erase it. Selected as highlight. There we go. All right, so this would now be hyperbolic sine. Why did I put an S? Of 3x. But again, we've got what here? Another inside. So I'm going to put a little blue this time. Write it off to the side. So we have an inside again of 3x. And I know it's a different I, but I still need to do it. So that would just be 3. So now we can take each of those and tack it on. So the hyperbolic sine of 3x times the 3. And so we end up with, I'm going to put the e at the end, 3 hyperbolic sine of 3x times e hyperbolic cosine of 3x. And there you have it. And then this one up here. There you have it. All right, so those are chain rules, one for natural log, one for exponential. Now let's try product. And how can you tell it's product? Because there are two x's. There's a multiplication sitting there. That's how you can tell it's product rule. So we're going to write these off to the side. I'm going to give a lot of room for that cotangent because it needs a parenthesis and a half. So you can see that we actually have chain rule twice here. Actually, we'll see. There's more than that. Ready? 1. All right, so hyperbolic cotangent. Hyperbolic cotangent is negative cosecant squared x. So we're just going to rewrite it like that. And then we're going to put whatever's in that parenthesis there. And then the square. Just like that. So that is how we do that. So this just gets brought down, and you see we're just replacing the cotangent with negative cosecant, forgot the h, squared. So that's it, those just changed. All right, but now we have to apply chain rule. So this is part of chain rule. So I'm just going to write it off to the side. and we have to take the derivative of that. So that was our inside. We now need the derivative of the inside. All right, so 1/2 x squared plus 1 to the negative 1/2 times, and this one we can do nice and quick, 2x, because there's an inside. And then we can simplify it. The 2 and the 2 cancel, so we end up with x over the square root of x squared plus 1. And then that gets tacked on to this one. So I'm going to rewrite it. Negative cosecant h. This 2 and the half cancel, so now we have just x squared plus 1 times that guy over there. All right, now we apply product rule. So it's 1 times this, so that would just be cotangent, hyperbolic cotangent, and we can actually just write it the way it is now, x squared plus 1. And then this times this, so it's going to be minus, and then x squared. I'm going to put the radical in front now, like that, that rational. That radical, not rational. That fraction. And there you have it, a very complicated, crazy problem that you need to take your time with. So x is 1, and then this would give us this, so we just replaced it, and then we take our inside off to the side, take its derivative and simplify, tack it back on, and then now we can apply product rule. So this times this goes here, and so we have negative x squared, square root of x1, cosecant x plus 1. And there are your derivatives. So you can see we're just tacking on to our derivative rule sheet, which I will give you at the end of this chapter.